Assalamualaikum and good day to our lecturer Mr. Hairul bin Bakri. Me and my friends from second year student BMMM section 2 will present our assignment, a topic about torsional loadings evaluation from actual structure. For this experiment, we decide to use manual impact screwdriver to be analyzed. A manual impact driver is a tool that delivers a strong sudden rotational force and forward thrust when struck on the back with a hammer. It is often used by mechanics to loosen screws that are corrosively frozen or over-torqued. The direction can also be reversed for situations where screws have to be tightened with torque greater than a screwdriver can reasonably provide. Manual impact drivers consist of a heavy outer sleeve that surrounds an inner core that is spined into it. The spine is curved so that when the user strikes the outer sleeve with a hammer, its downward force works on the spine to produce turning force on the core and any socket or word bit attached to it. The tool translates the heavy rotational nature of the sleeve to the lighter core to generate large amount of torque. At the same time, the striking blow from the hammer force the impact driver forward into the screw, reducing or eliminating came out. Those three features are part of the tool, which is one of them a handle. This hammer impact tool provides a free grip with its slip-resistant handle and chrome plating to resist corrosion and rust. Next is left and right rotation adjustment. Features permanently attach left and right directional markings on the front end of the handle. Adjustment can be made by pushing and turning top of the impact screwdriver. Clockwise is to tighten and anti-clockwise for loosening the screw. And the part below is removable adapter. This type of tool have removable bits holder to quickly and easily swap depending on type of screw used. Dimension of this tool is 183 mm height and 28.0 mm wide. If classified into parts, the length of the handle is 110.4 mm and the radius is 14 mm. For the rotation adjustment and removable adapter is 72.6 mm length and 22.6 mm for diameter of bit. So for the weight of this tool is 0.9072 kg. The material used is steel, and down below is the detailed material properties of steel, which is ultimate stress is 400 megapascal, 250 megapascal of yield strength, 200 gigapascal of young modulus, and 78 gigapascal for shear modulus. And next is a video to show the mechanism of how the tools works.
Salam sejahtera. My name is Bernard Anagiris. My matrix number is B091910308.
Salam sejahtera Encik. My name is Saravanan Ananiki Sankaraj and my metric number is B09191036 and I'm from class BMM section 1/2. Now I'm going to present about factor of safety for our project, which is impact driver. How to find factor safety is ultimate stress divided by allowable stress. The ultimate stress which is we get from our calculation is 400 MPa, and to find allowable stress we need to use the formula which is force divided by area. The force we get from our calculation is 24,014 Newton, and the formula for the area is pi r square, and the answer we get for allowable stress is 59.80 MPa. Now we use the formula of factor of safety, which is ultimate stress divided by allowable stress, and the answer for the factor of safety is 6.68. So the factor of safety our project is is 6.68 greater than 1 represents how much the stress is within the allowable limit. Thank you, sir.
Analysis and discussions. We have selected steel impact driver as a structure for our assignment. This is because steel is tensile. It has a high strength to weight ratio, which means it has high strength per unit mass. So no matter how large the overall structure is, the steel section will be small and lightweight, unlike other building materials. Steel also can be easily fabricated and produced massively. Steel sections can be produced off-site at shop floors and then assembled on-site. This saves time and increases the efficiency of the overall construction process. Structural steel is very flexible. You can mold it into any shape without changing its properties. Based on the result, the maximum shear stress is 336.2 kN per meter and the polar moment J is 6.034 times 10 power of negative 8. Given that the modulus of elasticity of the steel is 200 gigapascal, since the modulus of elasticity is high, the tendency of the material to deform along an axis when opposing forces applied is low. The yield strength is defined as the stress at which a predetermined amount of permanent deformation occurs. The yield strength for this steel impact driver is 250 megapascal. Shear modulus or modulus of rigidity is a measure of the elastic shear stiffness of a material and is defined as the ratio of shear stress to the shear strain. The shear modulus for our impact driver is 78 gigapascal.